Hello everyone. Today we're going to talk about dynamic programming, specifically the bottom-up approach. If you've watched my previous video about greedy algorithms, you might remember that greedy always makes the best decision right now. But here's the problem. The best decision right now doesn't always lead to the best final result. So that's where dynamic programming comes in. Dynamic programming is about solving a problem by using the best results from the past. And so without further ado, let's jump into the first example for today. Let's imagine a delivery robot. The robot starts at the top left corner over here of a grid and wants to reach the bottom right corner over here. And so each cell has an energy cost which robot has to consume to reach each cells, and the robot can only move right or down to make the minimum cost. So our goal is pretty simple. Find the minimum total energy cost to reach the destination over here. There we go. Well, for each cell, we basically compare the accumulated cost from the right and the bottom, as you can see, and select the smaller one and add the current map value to update the DP table. Well, before you do that, when it comes to boundary case, we first initialize the boundary of the DP table because those cells have only one possible direction. But the, the basic concept is exactly the same compared to the normal case. But what I mean by that is um, the robot has to move only right for the last row, but when it comes to last column, the robot has to move only down. So that's why we have to take care about the boundary case, but the basic concept is exactly the same compared to the normal case. And lastly, when it comes to direct array, it stores the right or down value in each cells. So there we go. Well, this is a map table, and we're gonna fill up the DP and direct table based on this map table. And so we have to consider this boundary case first, and then we're gonna fill up the normal case like this, which is backward, to ensure all future states are already solved. So this is our strategy. First things first, when it comes to DP table, we have to fill in uh, the value 1, which is the map value. This is about the initialization for the dynamic programming. And yeah, so we have to fill up the bottom right one. And then, like I said before, the robot has to go down all the time when it comes to this last column. And then we have to throw in the accumulated cost, which is 4. 1 plus 3 is 4, and 4 plus 99 is 103. And we're gonna do the same thing. 112 and 116. And what about the last row? The robot has to go all the right direction, and we're gonna add up 1 and 12 would be 13 and 45 and 99 and 118. So this is all about the boundary cases, and uh, we're gonna move on to the next normal case, which is go backward like this. So we have to consider this cell first. Well, we have to choose the right side or the bottom side, but in this case, our goal is to make the minimum cost, so we have to go right in this case, and then we have to add 4 and 7, which is 11. And what about this one? We have to choose between 11 and 45, but 11 is much smaller than 45. So it must be 18. With the same technique, it would be 19 with the right side and 22 with the right side. And what about this cell? Maybe we have to go down because 103 is much bigger than 11, so we have to go down to make the minimum cost. So it must be 15 because we add 4 and 11. And we have to go right in this case, and it must be 113. And when it comes to this cell, we have to go down, and it must be 26. And when it comes to this cell, it must be, yeah, we have to go down, and it must be 123. And what about this cell? We have to go down, and it must be 17. And we have to go right, and it must be 20. And this cell must be 22 with the right side. This must be 23 with the right side as well. Well, for this cell as well, we have to go down to make the minimum cost, 26. We have to go down with the cost of 27. And we have to go down as well, which is 26. And lastly, we have the choice of 26 and 23. And we have to go down at this point, and it must be 24. So, well, this is how we get the minimum cost to reach the destination over here. So if we follow this direction, yeah, as you can see, if you accumulate this value over and over until we reach the destination, it must be 24. So this is how we get the minimum cost in using the dynamic programming. Well, first things first, I'm gonna write down the basic code first. Well, I'm gonna label each direction, right, down, and arrive to make the code much readable. And it has the increment pattern like this. And like I said before, we need 3 different kinds of array, which is map, dynamic programming, and direct array. The same size. I'm gonna fill up the value in the map array. 1, 2, 3, 2, 9, 101, 7, 98, 4, and 99, 3, 1, 7, 7, 3, 19, 54, 32, 12, and 1. I'm gonna initialize using the function for the boundary condition. Well, first things first, we need to fill up the bottom right cell with the map value. This is how we trigger the dynamic programming. And we need to consider the boundary condition. is how we fill up the cell for the last column. And we need to fill up the direct array as well. We have to go down all the time. And we're doing the exactly opposite situation with going down, going right. This is how we take care of last row. We're going right. There we go. And then we have to consider the direct array when we reach the destination. So I'm gonna throw in arrived in this case. So there we go. This is all about the initialization. And we have to think about the normal case. We're going backward using double nested loop. Well, if the right value is smaller than the bottom one, I'm gonna select the smaller one, and we're going right. Otherwise, we're gonna select the bottom one like this, and we're going down. There we go. And then we have to update those values to the current DP value. We need to add the current map value as well. And we need to update the direct array with this value as well. There we go. And yeah, so I'm gonna print out the smallest cost, the minimum cost to reach the destination, and I'm gonna show you the process the robot moves. So I'm gonna print out each coordinate. And if direct is right, I'm going to print out go right. And I'm going to increment the next x value like this to move on to the next state, to the next cell, I mean. And if direct has the value of down, I'm going to print out go down. And then I'm going to increment the y value. And we can use the else, but I'm going to specify the situation. If we arrive to the destination, I'm going to print out arrived. And break it. So this is all about the coding part, I guess. Yeah, as you can see, there is the each coordinate, and there's the minimum cost, which is 24. I'm gonna compare it with this one. Yeah, it's 24, and it is 0, 0, and 1, 0, 1, 1, 1, 2, 1, 3, 2, 3, and 3, 3, 3, 4, and 4, 4, which is destination arrived. So on top of that, if you check out the dynamic programming table, and I'm going to compare with this. So if you take a look at this red color number, 24, 26, 27, 26, 116, 23, 22, 20, 17, 112, 123, 26, 113, 15, and 103, and 22, 19, 18, 11, 4, 118, 99, 45, 13, and 1. You know, in the direct, dynamic programming table, it has all the value of the minimum cost. And if you take a look at the direct array as well, it says the direction 2 is for going down. So it says all going down for the first row, which is 2, and going right, 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 and down, and again going down, down, right, down, down, going right, 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 and down, going right, 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 which is 1, and the value of 3 is arrived, which is exception. So this is all about the first example. Well, actually, a classic bottom-up example is Fibonacci sequence. So we throw in 0 and 1 in the index of 0 and 1 each, and we add up the previous values to come up with the current value, which is 1, 2 for third index, and so on, 3, 5 for fifth index, 8, 13, 21, 34, and 55, and so on. So I'm gonna show you this kind of pattern in the Visual Studio first with the bottom-up approach. Well, first things first, I'm gonna write down the base code first. I'm gonna make the Fibonacci sequence until 10th index, which contains 55, as we already went through. So we have to start from index, the second index, until 10th index. Well, we can get the current value using the previous values. There we go. And then I'm gonna print out the 10th index. It must be 55. 55. So this is how we get the value of the Fibonacci sequence using the bottom-up approach. Well, we still can use the Fibonacci example using the top-down approach. So we call F2 and F3 for the F4, which will be 3 after all. And in this case, we call F0 and F1, and it calls F1 and F2, F0 and F1. There you go. And then each F0 and F1 returns 0 and 1, and it's going to add up to come up with the F2, which is 1, and it must be 1, 0, 1, it must be 1, and if we add up, it must be 2, and 1 add 2 must be 3, so it come up with 3 eventually. So I'm going to show you in the Visual Studio using recursive function. Well, first things first, I'm going to write down the basic code first. The key concept of the top-down approach in dynamic programming is that we pretend that the function of Fibo is already made, so it must be 3. So I'm going to call Fibo n subtract 1. In this case, I'm going to call Fibo n subtract 2. And I'm going to add up and get the result, by the way. Then return the result. And there should be a boundary condition. If n is 0, we have to return 0 right away. What about 1? We have to return 1 right away. There we go. So if I execute this file, it says 3. What about 10? It must be 55. How about 37? It takes a long time to get the answer. So yeah, this is how we get the top-down approach. Well, as you probably can tell, Fibo 37 takes quite a long time, so we need the optimization. Well, when we call F2, we know the answer from this function calls, and we don't really need to call the exactly same functions in this case. So we need to mark some answers in some array. So I'm going to show you this kind of technique in the Visual Studio. Well, first things first, we need the array. And well, we need the magic number like this, and we need to initialize this array with the magic number first. And then if array n doesn't have the magic number, which is already marked with the answer, we will return it. And in this part, we can mark the result right away to make this code much faster. So I'm going to start from Fibo 4. It must be 3. What about 37? Which was, yeah, as you can see, it got much faster. There we go. So this is all about today's video, and I hope you find it very useful through this video. Thanks for watching, and see you in my next video. Bye, guys.